I'm excited about FastHTML because it empowers people building web applications in Python to dream bigger, build bigger, wilder things without needing to learn JavaScript. FastHTML brings to that stack what Modal brings to deployment. You can do the whole thing in pure Python, fairly complex applications without all of the like cross-linguistic complexity that could be really killer. Hello, Charles here from Modal. For today's webinar, I wanted to show how you can build full stack web applications that are like cloud deployed, have all the fixins of a sophisticated modern application entirely in Python using the combination of the fast HTML web framework and Modal for hosting. This is particularly exciting to me because one of the things that I really like about Modal is that it makes it possible to like build applications, like deploy services from Python without having to learn all the gory details of cloud deployment. You still need to know some stuff. It's not the same as developing on your local computer, but you don't need to know as much as if you were like building all this stuff by hand. And I spent some time learning Docker, learning Kubernetes, learning how to deploy things a couple years back, being like an ML researcher, tried to become an ML engineer. And it took me a lot of time to learn those things. And I was both learning like new syntax, like new tooling, while also trying to like wrap my brain around new ideas in like a distributed systems deployment. And with web applications, there's an even deeper problem, which is you have to learn like another language. You need to learn JavaScript, HTML, CSS, and then like contemporary applications have this very thick, complex stack around their deployment. It's written in a language that you are learning, and then it's like trying to solve problems that you haven't learned about yet. And there's like a great degree of complexity there, and you're like you have to learn these things like simultaneously. And so it's nice to be able to separate out and say like, okay, I need to learn like how the web works, and I need to learn some things about like how to build a client server application with a web page. But I don't want to be like learning JavaScript and TypeScript and all these things at the same time as I'm learning those ideas. FastHTML brings to that stack what Modal brings to deployment. So you can do the whole thing in pure Python, like one single file of Python for defining like fairly complex applications with all the power that comes from that stack, the like modern web stack, but without all of the like cross-linguistic complexity that could be really killer. I guess the other way to frame it is there are ways that you can build Python applications for the web these days, like Gradio and Streamlit. Those are really nice for building the kinds of things they are designed for. In Gradio's case, it's like machine learning demos. In Streamlit's case, it's like dashboards, analytics dashboards. They're great for that, but then there's kind of like a ceiling. There's a place of like full stack web development that you can't reach just with those tools. And then you need to like dive into all of this complexity. If somebody tells you to learn TypeScript and React, and now it's going to be 6 months before you are able to do anything fun. So we can avoid that with FastHTML plus Modal. So I'm gonna we're gonna walk through first their kind of like quick start. I'm gonna like live code some of their quick start guide and show it in action. And then we'll switch over to a fun multiplayer checkbox game, kind of inspired by 1 million checkboxes that you could deploy on Modal, and that uses like more Modal features, more fast HTML features, and is also just kind of fun. Okay, so I'm going to focus in on the fast HTML part here. I'm just going to imagine this little block of Python code is all the code that you can see. I'll zoom in even further on it. So this is like how you create a fast HTML app. It comes out of their library as fh.fasthtml. Very similar pattern to Fast API. If you've ever used Fast API, you create this like app object, and then you kind of manipulate this app object. You add routes, you add middleware, you decorate it, all kinds of things like that. It's a similar pattern to what we use in Modal. With websites, you have routes where requests can go, and then you respond to those requests. That's like structure of a web server. And the thing that makes it a web server and not just any other server is that the thing you respond with when you get a request is a web page, is like HTML, a document. And that's what's being constructed here. So this is saying when somebody makes a request to my app, I want to return this home page, which just has the text "Hello World" in it. Kind of the way that they want you to like think about building a web page is that it's a tree of these like Python objects, like is how you construct your web page. We're building this tree in Python that represents our document. So right now, this is a simple tree. It's got one thing at the root. That root has one child. We'll see that get more complex over time. So this is what we're returning from our home route here, just this document that says "Hello World" in it. Let's deploy this and see what it looks like. So we're going to deploy it on Modal, obviously. But I'm going to Modal serve FastHTML app.py. Great. All right. So that's deployed on Modal. Pretty quick to do that deploy. And let's run it. All right. So there's our web page there. It says "Hello World" on it. Let's go back and change that to make a change here. So we make that change. You'll see some stuff appear in the terminal of like containers spinning up and down, Modal like restarting our deployment, redoing our deployment, and go back, hit refresh, it's there. So FastHTML also lets you do purely local development. So if you wanted to set up a whole environment with FastHTML and all your dependencies for your server locally, do some local development before using Modal Serve, you can also do that. You'll get like slightly faster reloads, like a Modal refresh. You saw that took like, I don't know, 3 seconds, 5 seconds there. If you do it locally, it might be like 1 second or less. So it depends on like how complex the application is and how fast you want those reloads to be. All right. So what do we got here? I'm going to put the web page over here on the right. I'm going to kind of squeeze this in there. I'm going to zoom out a wee bit, a little bit of color on how we actually serve this thing on Modal, like what's the integration with between FastHTML and Modal here. So this is basically it. It's like actually like super nice because FastHTML uses this same protocol interface that FastAPI and a bunch of other Python web serving frameworks use called ASGI, Asynchronous Server Gateway Interface. So if you're familiar with Flask from like Python web development, that is a WSGI application web server gateway interface. The A is async, and so these like ASGI apps are frequently faster because you can do asynchronous concurrent stuff with them more easily. That ASGI framework is something that like Modal knows about, and we know if you return a Python object that implements this ASGI framework, we can turn that into a web application for you. So, you can serve anything on Modal. You don't have to serve ASGI apps. You don't have to serve Python apps. We have the ability to like, you just open up a port and we can, we'll route traffic to it, send back responses. But if you have something like FastHTML or FastAPI that uses this ASGI protocol, then we can just serve it for you super easily with this decorator. Apologies for the sniffles there, by the way. I'm just getting over a small cold. All right, looking up the stack, one more decorator, this app.function. This is like sort of where we define some of the like infrastructure needs of our function. So we wanted like a GPU accelerated, we wanted a GPU accelerated fast API app. Well, we'd have to put a comma in between our arguments because that's valid Python. And then let's actually just run NVIDIA SMI and print the outputs. This will be fun. I've never done this before, so this is going to be a do it live debugging. You'll be able to see what debugging, what it looks like when I do debugging. Okay, yeah. On every get, we'll do like output equals subprocess dot run NVIDIA SMI, and then capture output equals true, and that bad boy, that output, we'll put that into our app. I think it's just output.standardout, but what's a fast debugging workflow for if not for being able to quickly debug little issues? All right, let's refresh. We'll see any error messages down here. Oh yeah, there's actually there's a little feature of fast HTML here. Oh, well, I don't think we will be needing the debugging because we got it right first try. All right, there it is. So, this is the output of NVIDIA SMI. It's pretty ugly there. Um, but we've got it. All right, so let's see. So that's ugly. It's like this little B here is telling me it's bytes. I see all these these slash ends here. Those are the new lines. Actually, I think it might be as simple as just changing it to text equals true, which will force the output of that sub process to get turned into regular Unicode text. So all right, we got a GPU. Oh yeah, all right, it's working. That's a little bit nicer. Looks like maybe those new lines aren't getting aren't new lining. So with fast HTML, like kind of the idea is you get to make HTML documents using all the features of Python that you like list comprehension. So let's go in here, fh.p, let's do line, and let's do like for line in output dot standard out. So now I'm making a new paragraph element, a new P in the HTML for every line in standard out. So let's get the let's do this right. Let's see hx get equals change. I actually don't think I need the change event here. We'll see a little bit more about those HTMLX features in a sec. All right, so now we're redeploying. We'll have like a couple seconds. Ooh, all right. Okay, so we did something. fhdiv fh.p for line in output.standard out. Oops. What we want to do is dot split lines. All right, there we go. Split lines. Beautiful. Okay, and maybe I did need that hx get equals change because that might be why we have that have a little weirdness there with these all showing up, this thing showing up as a list. All right. All right. Okay, so now it's a little bit nicer, but it's showing up as a Python list. I know what I need to do. I need to turn that into a bunch of arguments to this. So every argument to this fh.div should be a child. All right. There we go. That'd change all those. So, doing this live just so that you can see like what it looks like to do some debugging here. Okay, there we go. We kind of got some extra new lines in there, but um, now we can see the wattage utilization of our GPU in our little fast HTML app directly from Python turned into HTML. Pretty sick. All right, let's change that route to /GPU. So we'll move that thing that we just built onto the GPU route. And now we're going to go through the Quickstart guide and see some more fast HTML features. All right, so we have our fast HTML page here. Let's pull up our Quickstart guide, put it over here. So we've got we were basically running off the Quickstart guide already with this example. There's some slight differences. So they have this nice convenience function fast app that does a bunch of things, not just an app, but also some like nice things like a router. So let's bring that in. Let's drop down to some of the additional features on top of like just the stuff that I've shown already. If you wanted to use JavaScript, I think I already said, like I framed this as like, oh, you don't have to write any JavaScript. If you want to do stuff with JavaScript, it's like pretty straightforward to integrate here. So they show this example with like adding some charting to your app with Plotly. If you wanted to do Plotly plotting instead of matplotlib plotting. So you can right here we're setting the like headers of our app. So that's here we're gonna bring in Plotly from a CDN, so we're loading some JavaScript from an external source. There we go. And what else are we doing here? We've got data. So this is what we're gonna put in our chart. Let's bring in some JSON, or the JSON library to handle that, and make ourselves a little charting route. Copy their route here. There's actually two ways you can set up routes. The preferred way, I think, for them to set up routes is this pattern here, where you have this RT route object. So it's like adding new like pages or routes to our web page. You could do that and decorate functions with names like get and post to determine like which HTTP verb, what happens when a particular HTTP verb is used to request something. So for our chart here, so we give it a name up here like chart and do dot get. Actually, let's change this home one over to GPU. Where were we? We're building a little chart demo. Add RT chart. Go back to serving our FastHTML app on Modal. And let's see what we get. We should get our nice little chart demo. There we go. So yeah, nice. Plotly charts are kind of nice, interactive, easier to make something like interactive than it is with like matplotlib, which is very much like just make an image kind of chart. Okay, so we did that by adding get route at /chart and using this like JavaScript feature here, where we're creating a plotly plot in JavaScript. Probably another 10 minutes, try the Quickstart guide, then we'll look at the checkboxes example. All right. Debug mode, this is a nice little feature where it makes it easier to like propagate up errors all the way back to the client, which is great when you're developing. So let's add that debug equals true. Check this thing out. Let's see. So let's make a new route with an error in it. Great. Have that over. We're dividing by 0. That's no good. You don't want that. Let's all right, fh dot titled. So because we're in debug mode, if we go to this, oh yeah, we need to give this route a name. Call it oops. So now if we go to oops, what are we gonna see? There we go. All right, so we get an error message back, 0 division error. Looks like you can see this error in the logs. But the nice thing about putting it in debug mode is that you can also sort of like see that error reported back to you. All right. Okay, we got oops done. Routing. Let's see. So this section's going into a little more detail on what I talked about previously. Like you put on routes, you give them names. That's like, which page a user is accessing. You can use variables to like sort of parameterize routes. So like, when you go to your home page on like your profile on a social media site, there's some URL with your username in it, and you land on your profile. And that's like, dynamically created, stored in a database and fetched. Let's grab this example, do something with it. Let's add this. Looks like this is name age route. All right, add in what library it came from, name.title, age equals age. One interesting thing to note, actually, let me call this out here. See those Python typing annotations here in the function signature. Those type annotations like restrict what is going to be allowed in a route. So let's go to /Charles age 2, run it. All right, we deployed. Yes, we're deployed. If I type in a word instead, I get a 404 not found because there is no there's no route that accepts the string in that position. So 404 not found. So you can set these types using like Pydantic, if you're familiar with Pydantic, very common in the Fast API ecosystem for doing this kind of like typing and sort of like validation, serialization and deserialization even. So you can use that from the FastHTML, in FastHTML land. Nice. So yeah, they talk about that a little bit. Yeah, return an error instead of a web page. All right, talking a little bit about HTTP methods and routes. Yeah, we haven't done anything that's a post that would change anything. So let's maybe do that. Let's see, HTTP get. Yeah, this one will do an HTTP post. Put that in there. This is to our base route. We got rid of the base route at the beginning and replaced it with that GPU one. So we don't have anything there. So let's put in a get handler so that when when your browser goes to a page, it like the initial thing it issues is a get, and then uh, post post request will get issued at some other time. I think we'll probably end up just doing a little curl to hit this thing. Okay, so get post, everything's looking good. Let's hop over here, jump back to our root HTTP get, handle get, beautiful. Let's maybe do a quick curl here. So what's this URL? Let's do curl-x post to that URL. So this is one way to do a post request. Look at that. Very nice. Now, see, that's a little bit, it's a little bit silly to look at HTML inside of a terminal, but that's what you got. Handle post right there. Because now we can kind of see a little bit more of like what, this is the detail of like what exactly is getting made for us by FastHTML. It's this HTML with like these headers up here are what we set all the way up back here with HDRs. That's where you can see we're pulling in our we're pulling in this script tag. We're pulling in this JavaScript library, and that is up here. Looks like, yeah, HTMX, that's part of how fast HTML does like interaction between client and server. We'll get there in a second. Yeah, you can see some CSS styles. Where's our Plotly? Maybe after. Oh, there it is. Right. So these are all default headers. This is like every fast HTML app is going to have something like this. This is the one that we put in ourselves down here. And of course, I would show you that in the terminal via the curl because that's just when we saw it. But nice feature of web development that people who've been doing like back-endy Python-y things you should be jealous of is that the browser has all this beautiful, awesome like debugging stuff built into it. So I can see the actual HTML here, the same thing I was just looking at there. And like I can change it, hello get. So nice, very nice for like quickly trying out a feature, like kind of messing with styles in particular, and debugging stuff. And it's hard to get this nice of a like debugging and iteration environment in a language like Python. You gotta work to set up things like Jupyter notebooks and iterative development. Because we're building web applications, we get all this nice web tech for free. First, I'll show you what it is that this like checkbox app that we're gonna build, and then we'll take a look at the code. So go fast HTML checkboxes. Yeah, modal deploy. Oh yeah, we were doing modal serve with that one where we were like live editing the code. That's for like fast iteration, like development workflows. Once it's time to like actually put something out for everybody in the world to use, that's modal deploy. Great. Okay, so here's our 10,000 checkboxes app here. You can see all these checkboxes. That's very nice. But I didn't check all those checkboxes. This is actually multiplayer checkboxes. I'm going to drop this link in the chat. You can go to that link and you'll be able to edit these checkboxes and we'll be able to see your edits and changes live. But while we wait for some folks in the audience to try that out, I'm going to actually just run a quick load test on Modal, some like fake users to try this thing out. We're going to do Modal run checkboxes load test. All right, so on this side here, we're like spinning up a load test. So we're spinning up a bunch of workers to hit our server. Okay, there we go. I have to zoom out a lot to make it look nice in the terminal. So you don't have to actually like clearly read the stuff on there. But what you can see coming in here are the actions of these users. They're sending requests to change these checkboxes. So let's drop in here. All right, and I think I spun up about 30 users, and they're checking on average like 5 checkboxes. Yeah, there we go. Okay, yeah, we see some checkboxes coming in and coming out. Hop in there. Let's maybe spin up some more users. This is what? Yeah, 5 requests a second on that checkbox toggle. We can do way better than that. So let's see. checkboxes load test. Let's add some more users, -u 100, spin them up at a rate of like, 1 per second. And then let's run this bad boy for 10 minutes. So this code is actually also all on the Modal examples repo, so you can see how this load test works in detail. It's using the locust library. And actually, there's actually a cool way to look at this. So this also, you can see the code again for more details on how this works, but it comes with this nice UI for watching the results of load tests. Looks like we need to spin up another one. So I'm just gonna, spin up, 10 more users, 1 per second. And now we're going to get some nice like charts showing us our load test happening live, so we don't have to read that like, terminal noise. Great. Okay, we got some requests coming in. So during ramp up with this app, things are a little bit slow when like a bunch of people come in at once, but then it speeds up once I start clicking checkboxes. Go back here. All right, we can see now some more checkboxes are disappearing and appearing. Clicking, and there we go. Boop. Great. We can see, look at here, we get the raw numbers from this load test with up to 100 users. And now we're at, 10 requests a second. I think it's still scaling up, like slowly adding more users over time. So 500 requests a second. Ooh, fails. Uh-oh. That's news. So let's see. Let's take a look. Not found for URL / checkbox / toggle. Not found for URL / div. Let's take a look. Do we have everything solid here? Let's see, checkboxes locus file, do checkboxes load test.py, do web dev.modal.run, checkboxes. Okay. Oh, you know what? I need to be serving that, and I was not serving it. I was, okay, So I'm going to do something a little bit naughty, and I'm just going to point the load test directly at the production version of the website. Don't do this at home, kids. But let's just point the load test there. And now let's modal run the checkboxes load test, checkboxes load test.py. And what did we do last time? 100 users, 1 per second, up for 10 minutes. Ooh, yeah. I guess maybe the clicks were folks actually playing with it from the audience. It looks like maybe somebody tried to draw something. Let's see. I hope it's not something that I'm gonna regret. I see some like patterns there. Maybe somebody trying to draw. Nothing popping out. Oop, was that it? There we go. All right, cool. So as we're doing a load test with the artificial users, the fake users, looks like we've got some real users drawing a little box there. That's nice. Let me click some in there. So delete a few checkboxes. There we go. Boom. Yeah, look at that. All right, cool. So, all right, our load test is running. Looks like we hit 50 requests a second, 50 checkbox toggles per second just from the load test. And things are running pretty smoothly. Looks like we got about 1 second to respond to a checkbox toggle, which is good. The the rate at which the sort of frame rate on this one is only 1 second. So we don't have to be that much faster. So cool. So there's definitely more to optimize with this application, by the way. Like we just kind of whipped out this quick like version of it that runs at a scale of 10,000 checkboxes, at a scale of up to 100 or so concurrent users, and 1 frame per second. There's a lot more optimization work that you could do. So let's take a look at the actual code to see how this gets served. Oh, maybe let's see. Turn off that load test. Start looking at this code here. There's like a couple components here that are like interesting. It still has the same like basic structure. Let me call this out real quick. It still has the same like basic structure as that like FastHTML app like tiny example that we did. There's like this modal ASCII app decorator that says whatever object gets returned from here, turn that into like this is going to be a Python object that implements the ASCII protocol. Let's, serve this thing as a web page. And then in it, we like import FastHTML and define like all of our routes. Like here's one of our route handlers, here's a route handler, here's a route handler. And and we return this like FastHTML app that we put these routes on. We return that at the end. So like same basic structure, we were like gonna be doing some more complex stuff with it, but the like that basic pattern is still there. All right, so a couple of notes on kind of like deployment here. So one important piece with using modal with like async Python like ASYAP is you are going to want to set this allow concurrent inputs number to something large. I think 1,000 is the largest that we have right now. We're going to boost that, but allow concurrent inputs 1,000. This means that like basically if you're sending a bunch of like requests, they instead of like Modal spinning up like one container per request, basically like up to 1,000 requests can go to a single container before we'll spin up another one. And if you're doing stuff async, if you have an async event loop going, those will be served concurrently. That's going to make your web server scale much better if you can take advantage of that. One note, depending on how you manage state, that's going to be that's the hardest part of this like multiplayer checkboxes thing. Where does this information about the state of the checkboxes go? How do you manage access to that information? So one just like simple choice that we made to just like make our lives easier in this first iteration of it is we set concurrency limit equals 1, so Modal only ever spins up a single container for our application at a time. And that means that we can maintain the like state, like which boxes are checked right now, who are all the clients. Like we could just maintain that in memory in one copy of the server, and we don't need to worry about like sending information between multiple copies of the server, having like a write leader and read replicas or followers or anything like that. That starts to get really complex really quickly. So we could get up to the scale that we saw 100 simultaneous users, 50 checkboxes a second, without needing to worry about that. Then the one thing that we do need to worry about, if we want this to like stick around forever, where like somebody leaves and they come back and if nobody messed with their art, it's like still there as a bunch of checkboxes, we need some form of persistence. And Modal offers a couple of different ways to do persistence. You can do remote file systems if you want, but for this, it's a bounded amount of information. It's like 10,000 bits, right? A bool for every one of the checkboxes that we need to keep track of. We want to just like load that if it's available, save it whenever the server shuts down. That way we could have this be fully serverless, right? Otherwise, if we just kept it in memory, like if that was the only place a state could be, then we would also like we wouldn't be able to like spin down when nobody's using our application. And that's a really nice thing about Modal, that you get like the resources that you need for your application. They only come online when you need them, and that means you only need to pay for them as you're using them. And so a modal dict is a great way for doing that kind of persistence. It's also great actually for communicating between workers. So you can actually do it to do that kind of like communication of state between replicas if you want. But here we're just doing it to like store information in between times our server spins up. And great. So that's our dict. So those are the kind of important things. Maybe I didn't call this out that explicitly before, but this is our like container image. So this is like what does our server need installed on it to run? So that's like where we're installing fast HTML and like any other dependencies. We have a tiny little dependency in this one for making that nice title 10,000 checkboxes dynamically, depending on how many checkboxes we have. I think that's where is that? Right, in our top level root here, this inflect. This is great. This is like a great little tiny Python trick, by the way. This inflect library is like, parts of speech, pluralization, turning numbers into words, words into numbers. Very cute, fun little library. And those tiny, fun little libraries are part of the delight of Python. Managing their dependencies is part of the pain of Python, and making these like separate images per server, per like component of your application. a great way to avoid that pain and still get the joy of using these like cute little special purpose libraries. Let's talk a little bit like, okay, how do we actually implement this? Let's go in. So we are going to use like in a couple of places, we're going to like protect some information, some shared information between clients so that like if they both try to change a checkbox at the same time, like one sees one state of the checkbox, like and they can't like change it underneath each other. So we do that with an async IO lock, so that to like protect access both to like which clients are being used and like what the state of the checkboxes is. Let's see. So, oh yeah, by the way, so this is where we're getting the checkbox state. Like we keep them in memory during operation, but persisted to a modal dict across starts. So that's and like getting stuff from a modal dict, you can do .get. You can actually just access it the way you do a normal dict. Depends on how you wanna do it. Also with that like persistence, this is the like async def on shutdown. This part here, Modal has support for ASCII lifespan events. Lifespan is like there's some things that you want to define as happening when the server starts, when it shuts down, and that's these lifespan events. This is where we say, oh, we're shutting down. Let's like save the checkboxes, like the state of the checkboxes on Modal. So you can see we're just like accessing that. Yeah, we've got headers. This is where we're putting in our CSS styling for that page. To get files onto Modal, there's a couple different ways to do it. The one that we used here is Modal mounts. So like our CSS files are available here locally. Let's see, styles.css. So I can look at them and edit them locally. And to get that file on Modal, we do this like modal.mount.from local file. And that's where we get our CSS style and pass them in as a FastHTML style object. So let's maybe look at, what does it look like to like toggle a checkbox? So yeah, these are Booleans, so toggling a checkbox is just not. So we like quickly lock, don't let anybody else change the checkboxes, change their state, and then push that information out to everybody else. So other people who are like on the page get information about what change happened. So how do those people find out about it? The clients poll for outstanding diffs. So we're doing like a polling architecture here. Because we're only going for like 1 a second, that works fine. If you wanted things to be faster, you would want to do something else. You would want to like do like server sent events, I guess, or something like that. And that's this. So that's handled by this diffs route that like a client asks for this, says, hey, what do I need to do to update the state? And so we set that information when anybody touches a checkbox. We set that information, and then in this route this is where we send the information to people who request it. We send back our like checkbox, our set of diffs. So let's see, is there? All right. So then, like, how do we set that up? How do we set it up so that that diff gets pulled every second? That happens when we send out an HTML page, we include some extra information in it that says like, oh yeah, every second the client should pull this route. So that's down. Oops, that's down here. Use HTMX to pull for diffs to apply that. So that's down here. So this is a part of FastHTML that I haven't talked about that much yet. So HTMX is a way to only write HTML. When you're writing it, it's like HTML with some extra extensions, X for extensions. FastHTML uses that so that you get interactivity and so that you get, asynchronous execution as you would want in a user interface, but without needing JavaScript. That's like the typical way of solving a problem like how do we make sure that a client hits a route every second is to use like client-side JavaScript. But here we're doing client-side HTML or HTMX to get that to happen. So that's all these HX, these arguments that begin with HX on our FastHTML construction calls here. So we say every 1 second, do a get at this route, diffs client ID. That was the route we were looking at down here, right? Diffs client ID, call the diffs endpoint. And then you, like with HTMX, you get back like some kind of like HTML fragment or whole page or something, and you need to say what happens when I get something back. Like when you call this get, is that like get it and then like that's the whole new web page? That would be like, that would kind of suck if every second you had to like reload the entire web page. That's bad. And one of the things that these like fancy JavaScript client like frameworks do is they have like smart ways to only change part of what's rendered on the web page in response to these requests. And that's what HTMX does as well. So you have this HX swap logic that says like, what should I do with this? So this says like, don't replace the entire page, and we instead say like, we're gonna pass things back by and with an identifier, and that allows us to know like which checkbox to change. So I think we can see that pretty clearly here. Let's see, HX post. All right. Yes. So we send back this array of diffs, and we say like swap things with this ID. So we have an identifier here, and that's how we know how it knows what to swap. And then we activate, like normally you can only swap maybe like the component that was like that where the request came from. That's like an obvious logical thing to do, like the component or its children's children, like that part of the tree, that subtree. I think that's the default behavior. And then if you want to be able to like reach outside of that, which is going on here, that's this HX swap out of bounds OOB is true. Okay, so like what do we talk about today? Like high level what's going on here. So I'm pretty excited about FastHTML because it empowers people building web applications in Python to stream bigger, build like bigger, wilder things than you could then like radio or Streamlit allow you. And like get your feet wet with building stuff on the web and with like web tech like HTML and HTMX without needing to learn JavaScript, which is like, it's a big lift. Big lift. I've learned it. I can, and I do stuff in it, but it's not my like native language. And it slowed me down a lot. So I'm excited about FastHTML, and it happens to work super well with Modal, which I'm also very excited about. We build lots of things like internally. We build dumb little apps. We build like pages. We build internal tooling. And once you add like a second language, even if you have people who like speak both languages pretty well, having two languages just makes everything more complicated. Like now you've got like two different stacks. How do you send information between these two things, between Python and JavaScript? Like, yeah, it increases your complexity pretty quickly. And so being able to build an app on Modal, like get Python all the way through, is really sick. So I'm excited about this. Going to keep building things with FastHTML, trying out with some of our examples where we use JavaScript, where we use React, or where we use like Alpine or Svelte or whatever. If you end up doing the same, whether you're using Modal or not, I'd be interested to hear what you build. Given that this comes from Answer.ai, I also expect they're going to be interested in things, chatbots and image generation and other uses of neural networks. And then the problem with deploying something like that is now you got to get a hold of a GPU to make it run fast. And so hopefully, if you want to build things like that, build them on Modal, let me know. But whatever you end up building, I'd love to hear about it. Love to hear how you end up using FastHTML. So yeah, please do reach out to us, modal.com/Slack to join our Slack community, or reach out to me on Twitter, Charles_IRL, or to the official Modal Twitter, Modal_labs, to let us know what you've built. Looking forward to it, and I will see you around. Take care. DIY AI on a